Hey guys, so we're continuing with our Regents review. This one says, base your answers to question 21 to 23 on the map below and on your knowledge of Earth signs. The map shows the locations of Jamestown, Watertown, and Kingston in New York State. Compared to the time of sunrise in Kingston, the time of sunrise in Jamestown would be, the answer is 20 minutes later. So it's asking about sunrise and sunset. It's not asking really about the exact times of these different places. So if you go on your Regents Review packet, 19, page 19, you'll see that the Earth's rotation eastward causes sunrise and sunset to happen first in the eastern part of the world and later in the west. So in this example, sunrise and sunset will happen in location D before C, A, and B because D is farther east. That's why compared to the time of sunrise in Kingston, since it's towards the east, the time of sunrise in Jamestown, which is more towards the west, will be a lot later because sunrise and sunset happen towards the east first. So to figure out how much later, remember, time zones are based on Earth's rotation eastward at 15 degrees longitude per hour. So this affects the time in different longitudes, and a 15-degree change in longitude will be an hour difference. So let's see how much time, how many longitudes are, or how many degrees of longitude is between Jamestown and Kingston. So starting at 79, 1 degree, 2 degree, 3 degrees, 4 degrees, 5 degrees. So it's 5 degrees difference in longitude between Jamestown and Kingston. Every 15 degrees is 1 hour, so that can be two. It can be 1 hour later. The time of sunrise in Jamestown must be around 20 minutes later, less than 1 hour. And it's not earlier because sunrise and sunset happens in the east first. So Kingston will have sunrise and sunset earlier. 22. An observer in Watertown, New York, would see the star Polaris at an altitude of approximately, the answer is 1, number 44 degrees. Remember, based on your Regents Review packet, page 10, the latitude of a person, the horizontal lines, equals the altitude of Polaris in the north because Polaris is in our north star. It can only be seen in the north. For example, if you're in the 30-degree north latitude, your altitude of Polaris in the sky will be 30 degrees. That's why, since Watertown is at a 44-degree latitude, the horizontal line, it will be the altitude of Polaris will also be 44 degrees. So 23, Earth's system of longitude is based on which motion? The answer is Earth's rotation. Once again, Regents Review packet 19, page 19, Earth's rotation eastward at 15 degrees longitude per hour affects the time at different longitudes. So that a 15-degree change is a 1 hour difference. So that's why our Earth system of longitude is actually based on the Earth's rotation. Okay. 24. During which season in the northern hemisphere? So let's start here. The diagram represents Earth orbiting the sun. 4 positions of Earth in its orbit are labeled A, B, C, and D. Letter N represents the North Pole. Distances are indicated for aphelion, Earth's farthest position from the sun around July 4th, and perihelion, Earth's closest position to the sun around January 13th. So let's see, aphelion is the Earth's farthest position from the sun. That must be here. It's giving us a longer number here. And perihelion is the Earth's closest position to the sun. That must be here because this is a shorter position, shorter distance. Okay, so during which season in the northern hemisphere is Earth at aphelion? Aphelion is the Earth's farthest position from the sun, so that must be around here. And notice that the Earth is northern hemisphere. Where I know this is northern hemisphere because it's the North Pole. It's tilting towards the sun, and when the Earth is tilted towards the sun, it's actually July for us. It's summertime, but the Earth is farthest away from the sun at aphelion. And when the Earth is, and notice that we're getting more hours of sunlight in the northern hemisphere when the Earth is tilted towards the sun. That's why it's summer. 25. Between which pair of lettered positions is the sun's vertical ray moving from the equator southward to the Tropic of Capricorn? The answer is 4, D, and A. So it's asking in between which letters is the sun's rays, direct rays, meaning 90 degrees, or vertical rays, 90-degree angle, is the sun's rays going from the equator south towards the Tropic of Cancer. Well, remember, these are our seasons, and during September 21st, around that time, and March 21st, the sun's direct rays or vertical rays or 90-degree rays or most direct rays are at the equator. So the equator sees the sun directly above or at zenith, right? And then this is also in your Regents Review packet, page 23. On March 1st and September 21st, the sun's direct rays are at the equator, and that's why it's at zenith for us. But on December 21st, we see our sun's direct rays are more southwards in the Tropic of Capricorn, 23.5 degrees south. And then June 21st, our sun's direct rays are more northward at Tropic of Cancer, 23.5 degree north. So if I come back here, it's asking for the vertical ray moving from the equator southward to the Tropic of Capricorn. So this must be D, because that's when the sun's rays are at the equator directly. And then when we come at A, this is winter time. The Earth is northern hemisphere is tilted away from the sun. The sun's vertical rays during the winter time are hitting the Tropic of Capricorn, 23.5 degrees south. So in between these two areas, are we gonna have the sun's direct rays moving from the equator southward towards the Tropic of Capricorn? Next, 26. Approximately how many times does the Earth rotate as it moves in its orbit from position A back to position A? So how many times will the Earth rotate if it goes from here and revolves around the Earth all the way back to here? Well, remember, one full revolution around the sun, sorry. The Earth's one full revolution around the sun is 1 year, and 1 year has 365 days. So remember, revolution is a year, so one full revolution is a year, 365 days, and one rotation is a day, 24 hours. So if it's 365 days from position A back to position A, and each day is 24 hours, then or one rotation is 1 day, then the Earth must rotate 365 times, because that's 365 days in a year. 27. What is the tilt of the Earth's rotational axis relative to the line perpendicular to the plane of the Earth's orbit? The answer is 23.5 degrees. So that's just asking for the tilt of the Earth. And if you go to your Regents Review packet, page 17, seasons are caused by the tilt of the Earth of 23.5 degrees. 28. Base your answers to questions 28 through 30 on the map below and on your knowledge of Earth science. The map shows a composite of Doppler radar images. Darker shadings indicate the precipitation pattern of a large solar storm system over the eastern United States. So Doppler radar images are images that we use from looking at wavelengths. Okay, so the dark shading is indicating precipitation patterns, meaning this is where we're having a storm. Remember, storms happen, and any sort of rain or precipitation happens in a low pressure system. So if we go to your Regents Review packet, page 15, the low pressure system in low pressure systems, remember ILL, we have inward flow, lousy weather, meaning wet weather, meaning lots of precipitation, light or rising air, the air is moving up because it is less dense and it's going counterclockwise or left. So that's why, since we know this is a low pressure system because there's precipitation, it's going to go inward and counterclockwise. If it was a high pressure system, there would be no precipitation. 29. The best evidence on the weather map to indicate high-speed winds near the center of the storm system would most likely be number 4, isobars drawn close together. It's asking for high wind speeds. And if you go to your Regents Review packet, page 11, we're looking at isolines on a map. So remember, isobar shows pressure. So if we were to use isobars to show pressure of the high-speed winds on this map, then the line spacing of the isolines would have to be closer together to indicate faster winds or even faster streams. So it's the best evidence on this weather map, to indicate high-speed winds would likely be if my isobars, pressure isolines, were drawn closer together. 30. As the storm system follows the normal storm track, it will most likely move towards the correct answer is 3, northeast. Because we know this is the U.S., right? It says Eastern United States. So remember, the U.S. and particularly New York is around 42-degree north latitude. If we also go to Regents Review packet, page 15, planetary wind belts in the United States follow the normal storm track or path towards northeast. And because the reason is, if you go to your reference table, page 14, so the U.S., or particularly New York, is around 42-degree north latitude. And if we look at it on our reference table, page 14, around here, where the 42-degree north latitude is, the planetary wind belts are moving northeast. That's why our major storm systems also move northeast. That's our normal storm track. And that's it. Thank you.